welcome to the 2018 Radiation Medicine Summer Series. Each year, we select a theme beyond our regular focus to inspire us to expand our horizons. The topic this year is how artificial intelligence and robotics are transforming our lives within and beyond medicine. To kick off our series, I'm delighted to welcome Dr. Goldie Nejat. As you can see there, she's representative of many different initiatives and leadership and thought leaders. She's the Canada Research Chair in Robots for Society and a director of the Institute for Robotics and Mechatronics at the University of Toronto. She's the Associate Professor in the Department of Mechanical and Industrial Engineering and the founder and director of the Autonomous System Biomechatronics Laboratory. She's also an adjunct scientist at the Toronto Rehab Institution. She's going to speak to us about the future of elderly dementia care, socially assisted robots that can help provide care. Dr. Nejat.
Good morning, everyone. Thank you for joining us. Thanks, Rebecca, for that kind introduction. Can you hear me okay? Yeah. Okay, perfect, good. Then I may step away a little bit from this. So are you guys ready to talk about robots this morning? Perfect. So I just wanted to maybe give an introduction of the type of robots we do. And we design what we call socially assistive robots, and they fall into this class of assistive robots. And really what assistive robots are robots that help people. And they can help people in a number of different applications. Healthcare, of course, will be one that we'll discuss today. But they can help you in the home. They can do mundane tasks. For example, load and unload the dishwasher. Robonaut, which is one of the robots that was on the International Space Station, can help astronauts do maintenance tasks around the International Space Station. There's robots that are helping soldiers on the field. Robots that help find victims after a large earthquake, and companion robots that can be used for children as well as older adults to provide social stimulation. So these class of robots really fall into two types, the non-interactive and the interactive. And today we'll talk about this interactive, which is really an emerging area of robotics. Most of the robots you've seen are robots in manufacturing, self-driving cars, space robots, for example, like the Mars rovers. They don't really have much interaction with people, and the type of interaction is definitely far from natural. But these robots communicate in natural ways, so they can speak, they have gestures, they have facial expressions, and so they promote communication with people, and that's the fun part about it. So what we're looking at is designing what we call human-like socially assistive robots. So they have those capabilities to interact with people, and we've been focusing on helping older adults, especially older adults living with dementia. And what we want to do is provide them with assistance with activities of daily living to promote independence, as well as provide social and cognitive stimulation through leisure or recreational activities, so brain training, for example. And what we want to do is really have these robots autonomously interact with not only one person, but a group of people and provide person-centered care. And these are some of our robots that I'll talk about today. So really what our focus is on is finding what activities that older adults need assistance with, whether it's at the home or long-term care or retirement homes. These have been our three main focuses. And what we want to do is then provide assistance and see, really originally what we were deciding to do was see how people react to robots. So we're looking at a user population that has probably never seen a robot before in person or interacted with one. So is there any acceptance of the technology? Would they interact with the robot? So we did that initially, and then we moved on to supporting them with different activities as well. So the types of activities we've been looking at for it's about 12 years or so that we've been working on this, has been anything from meal preparation, so targeting older adults who skip meals, for example, and don't get the proper nutrition, so the robot can go find them, escort them to the kitchen, and the meal preparation activity becomes interactive. They can provide recipes to the person, help them find items or products in the kitchen. Clothing recommendations, so based on the weather, the activity, and even the person's favorite outfits, the robot can recommend what to wear. Exercise training, of course, is important. We focus mainly on upper limb Exercise, so repetitive exercise with the robot being a motivator. And reminders, which is an important one, so medication reminders, self-care reminders, brushing your teeth, for example, in the morning or before you go to bed, going to appointments, and then using the robot as a medium to connect to other people. So connecting with your social network. So whether it's your children that live in a different city, you can use the robot kind of like video conferencing on wheels. And then we've done some fun recreational activities, trivia, bingo, and playing memory games with just cards. So I'll show you our first robot, Brian, just to give you an idea of what our robots look like. And then I'll talk a little bit about the studies we've done with Brian. So here's Brian, human-like, kind of a waist up.
What is your name?
2 arms, a face that displays facial expressions.
Nice to meet you, Guam.
And then the
Let
voice.
me tell you a little about myself. I am a non-contact, socially interactive robot developed
Well, it's very robotic, right? You still
systems
see the
in
metal, the wires, and it's done
Biomechatronics.
all on purpose. And you can also hear the motors, right, moving. So the idea is we're not trying to trick people that these are humans, these are robots, so they look like robots and sound like
My
robots.
primary objective is to be
Okay, so that's Brian. So one of the first activities we looked at Brian providing assistance with was card games. In particular, matching card games. So if you remember this game even when you were a child, you have picture cards, they're flipped over and then you flip them over 2 at a time and try to match the pictures on the card. And so Brian is autonomously trying to facilitate that game with a user. The robot doesn't know how the cards are flipped, so you can put them in any order you want. It just sees whatever the player sees, but it can provide hints. So if it's seen a card before, it can tell you, why don't you choose this card, or give a general area that you could go and look for a card. And the idea is that we're trying to give that stimulation for, if we can, anywhere between 10 to 20 minutes. And this could be repeated throughout the day and weeks and months and so on. So while we're doing that, we wanted to figure out, well, is the user actually playing the game with the robot? Because there's no point the robot facilitating the activity and they're distracted, right? So we discussed to design the robot to have different sensors. And one sensor we wanted to use was the Kinect sensor and a webcam. The webcam is here on the shoulder of the robot, and it's used to detect the face orientation of the person, right? So are they looking at the robot? Are they looking at the game? Which means are they engaged or distracted? And we took it a step further and used a Kinect sensor to detect the body as well. So how are they oriented with respect to the robot? And the combination of these would tell us if they're engaged or distracted or going to be distracted. And we would use that to try to re-engage them in the activity. And we can do that with the facial expressions of the robot and vocal intonation. So we defined something called an accessibility level. And these combination of the two tell the robot if the person is accessible, which would be a level 4, or least accessible, which is a level 1. And then we could change the behaviors. So what we did was, after we did that, we thought, okay, let's start our first pilot study and just see how people react to the robot. So we took it for 2 days to a retirement/long-term care facility, and we put it on a first floor communication area where residents come and play cards and have coffee, or just sit and look out the window. And what would happen was people walk by, Brian would ask them if they want to play the memory game with it. And we didn't intervene at all, we just sat back and just watched what happened for 2 days. And we had about 40 older adults come and interact with Brian. We didn't have a specific target group, so we had any individuals from normal cognitive levels to mild Alzheimer's disease come. We also had an exit questionnaire, and 22 of them also filled out that exit questionnaire as they left. So what we wanted to look at was the main things: acceptance, and in doing so, we could look at how they're engaged in the activity. Are they even engaged with the robot? As well as their compliance. So when the robot gives them a hint or asks them to flip over the cards, do they actually do that? And so this was interesting to see. With engagement, we just categorize it into all the time, some of the time, or none of the time. And you can see how high these numbers are. And then the same with compliance, how high they are. The interesting one is this one, the one participant who complied none of the time. He was an older gentleman that had a hearing aid. because we were in a large communication area, we also had very loud speakers set up so that people could hear the robot because of the background noise, and that was causing interference with his hearing aid. But he sat there for 10 minutes trying to interact with the robot before he had to get up and say, I can't do this, which teaches us a lot because we're incorporating these into people's already existing lives. So we have to be, aware of the other types of assistive technologies that they're using or devices when we integrate our robots into their daily lives. So from the exit questionnaire, we measured a few different things. So we just did a Likert scale from 1 to 5, and we asked them things like, would they use the robot again? Would they trust the robot? Do they find it easy to use? Because this was all through natural communication, just like human-human communication. So highlighting some of the good, attitude towards using the robot was fairly positive. Intent to use was fairly positive. And then looking at trust, which is pretty neutral, right? But it made sense. It was the first time they were meeting a robot, first time they're interacting with a robot. And if you even think about human-human interaction, you wouldn't trust someone right off through that initial interaction, right? Trust is something that's usually earned over time. And so this wasn't surprising to us. It's interesting to see, as we have repeated interactions with our robots, how people actually interact with them, and that trust level actually does go up. But it makes sense, right? So it was interesting to see. As you can see, nothing really negative, which was really shocking to us too, that they were positive with the interaction, and it was some type of technology that they were willing to use. And so that kind of opened up the whole field for us, and we thought, well, that's great. We could do other things with the robot. Before I show you another activity, I just want to show you what we asked them to rank, what their favorite or their highest characteristics that they liked was. And you can see that the different emotions through facial expressions and tone of voice was the highest, and then robot's human-like voice and its lifelike appearance was tied for second. So that told us that they like this natural communication. There have been lots of studies, particularly in Japan, that mention that gender has an influence on acceptance, and so does computer experience. And so we wanted to try that out as well to see if it was the same thing here in Toronto. So you can see with most of our participants, they're mainly female, living in long-term care. But we looked at two things. So first, the computer experience. We asked them if they had any experience, just beginner experience, which was maybe they could do very simple programming, or in this case, use simple programs, I should say, like Microsoft Office or something, right? Or send emails out to family. Intermediate, they can actually surf the net, do video chats like Skype, and then, of course, the advanced, that they could have some programming background as well, more complex things with Excel or something. And so you can see kind of the distribution between there. And then we looked at gender and computer experience. So gender on intent to use and perceived enjoyment. And we found in our study, actually, there was no statistical difference between the males and females. And then we looked at computer experience and perceived ease of use of Brian. And we found that both female and male participants, regardless of their computer experience, found the robot easy to use. So that told us that we should really design these robots to communicate naturally, right? So there's no learning curve in using the technology. They can just use it straight out from their first interaction with the robot. And this is very important for our user group, people with cognitive impairments, right? So this was good for us. So it meant, because lots of people had, concerns about human-like. The idea of pet-like robots was different, and they had been used before in Japan and Europe, but a human-like robot, which talks like a human, people were worried that that could cause negative effects. But as you can see, we've had positive effects so far. So we tried now an activity of daily living, meal assistance. And what we did was we spent a few days at a local long-term care facility in the dining hall, just to see what was happening during meals. And we noticed, there's a 1 hour window, all the residents are escorted to the dining hall, they eat, and then after the hour is done, they leave and go to other activities. And you have 3 groups of individuals, ones that can eat on their own, ones that get distracted and need prompting to eat, and the last group that need to be fed. So we targeted the middle group. Because we were noticing, you know, at a table, for example, there's 4 residents and 1 care staff helping all 4, and it becomes a little bit difficult to make sure that each individual is eating all their meal, especially the nutritious part of the meal. So Brian now becomes a social interaction tool to prompt a person to eat the contents of their meal. And we wanted to make it social in the sense that meal eating or meals are usually social events, right? You do it with your family, your friends, you talk. So there's that social element, of course, as well as the cognitive stimulation. So this is what Brian looks like. We use still the Kinect sensor. This time we put Wii remotes on the robot's shoulder. So if you notice, we're using these off-the-shelf technologies. And we're doing it on purpose because we're trying to keep the cost of the robots down. The first assistive robot was $500,000, and that came with no software. It was just the hardware. So you had to program everything. But we built Brian for less than $2,000. So hopefully, and I'll show you a more commercial, or commercializable, I should say, like robot. So this helps us a lot, right, by using these gaming consoles. So that really helped our world. We also designed a tray so we could actually look at meal consumption. So all it has is some load cells to measure the amount of food, what we called on a main dish, a side dish, a beverage. Now we also noticed during meals that older adults would take the food and put it in a napkin in their lap and make sure nobody notices. And it would try to put the robot too, right? So we needed to detect that. So we used the Wiimotes for that. We developed we took a regular utensil that they use, took some LEDs, just a ring of LEDs, and put it on at the top of the utensil, and this was tracking it. So we were getting really triangulation of where the location of the utensil was. Was it at the plate? Was it at the mouth? Or anywhere in between, right, if they were trying to throw it into their lap. So that's really the design. So it's not too complicated, and then we have all the different behaviors of the robot, and I'll show you videos to get an idea of the behaviors. And then we took it, again, to long-term care, and we invited residents to have 2 lunch meals with Brian on 2 separate days. And in this case, we actually managed to find an older cohort, which was great for us, 82 to 93, 5 females and 3 males. And I'll show you the robot's behaviors. This video is just a graduate student with the robot, and then I'll show you the user studies themselves. So here's Brian providing assistance, just to give you an idea of some of those behaviors. This is the welcome, providing the menu.
Hi, my name is Brian.
Hi, Brian.
You look very nice today. Please join me for lunch. Today's menu includes some pasta, apple slices, and water.
So these are kind of the beginning.
What a beautiful day it is today. I'm glad I get to spend some of it with you.
And you may see the robot smiling in that part. And then here's the prompting. So there's 2-step prompting.
That's a good helping
pick up the food,
up there.
and in this case, after you pick it up,
Take a bite.
bring it into your mouth and take a bite.
Knock, knock.
Who's there?
Lettuce.
Lettuce who?
Let us in and we'll tell you.
So the joke's not as funny as the robot laughing, that's funny, right? So they're all meal-related or food-related jokes, and graduate students develop them. So here it is now with our user studies.
My name is Brian. You look very nice today. Please join me for lunch. Today's menu includes some beef stew with a side of apple sauce and a juice.
Yeah. Are you going to eat too?
And so this is our first step to obtain
It
food.
smells amazing. Why don't you pick up some food with your spoon?
I will. It's very tasty, Brian.
So this is for the social aspects.
I hope you are enjoying your meal.
I'm surely enjoying it. It's very good. I thank you. And I thank you for your company.
So when I go to do international talks, I say she's a perfect example of a Canadian. She's so polite to the robot. She makes So now, if you haven't had a sip of your beverage, Brian can prompt you to do that as well. And maybe I'll show one more.
Stay in shop. Your company. I hope we can do this more often.
I hope so. I hope I see you again. And you see, I never forgot your name. I remembered, and I was looking forward to meeting you again.
So it was really interesting for us to notice what they were saying back to the robot. And if you notice, the robot just says its prompt or the social utterance, and then it moves on. At this point, we hadn't incorporated any speech recognition, so it was just that saying and moving on. But they would talk to the robot, and they didn't care that it didn't respond back, which was really interesting to us, because we would want it to, right? So what we did was then we looked at the same thing as before, engagement and compliance, but because they spoke so much to the robot, we also wanted to see how much they spoke to the robot, so which we categorize as total number of utterances towards the robot. So you can see here, depending on each individual, we had people spending almost an hour with the robot eating to as little as 10 minutes, roughly here. So the average time was about 20 minutes or so. And you can see, we looked at focus of attention. So the focus of attention towards the robot or meal is pretty high, 98%, which was great because that's what we wanted. And the amount of time they spent actually manipulating the utensils themselves was 69%. So they did actually spend some time interacting with the robot. It wasn't just about the meal eating, and that's what we were hoping. And then you notice how much they spoke to the robot. So on average, it was 36 utterances. And you can see that obviously the longer they stayed with the robot, the more they spoke. So 86 utterances for the first person in just an hour's time, which is a lot towards a robot that doesn't respond, right? So, which was great to see. So, because initially we're thinking we have to design these robots to be very accurate, be very responsive, but we're seeing the opposite here, right? That they're okay with it not being responsive. They enjoy the company, and the prompting really helps them. So then, with compliance, we had 87% compliance. The only person that really didn't like listening to the robot was participant 2, and this was because there was eggs for lunch one day, and she didn't like the eggs. But she was still responding in the sense that whenever the robot prompted her to eat the main dish, she would eat her side dish. So she would comply in that sense, and even though the robot said it over and over. So we do have to think of different behaviors to get people to eat, especially the most nutritious portion of their food. But it was interesting to see, so she still tried to comply. So from that, then we decided, let's take it one step back. So we're done meal eating, how about meal preparation? So looking at personal or private homes and having a robot assist them with that. And Brian is not mobile, so it sits somewhere and usually you come to it. So at in the dining hall at a table or in the games room for the card game. So we developed CASPER. And CASPER, the nice thing about CASPER is it's 3D printed. So unlike Brian, that looks very metal, right? It's all plastic, really. And that also keeps the cost down because we can do it right in the lab. And CASPER is human-like. Can you tell why its name is CASPER? I don't look like the friendly ghost. Yeah. So that's why we gave it CASPER. And so the idea is that the robot, once it's mealtime, will find the resident, take them to the kitchen, and start preparing the meal. So I'll show you a video of CASPER just to give you an idea.
How are you doing today?
And it also has facial expressions. Brian's was a deformable face. CASPER shows them that we have. So we can have any type of expression we want, just using the mouth and the eyebrows.
I can be useful for many different tasks around the home.
We've tried different voices for the
My
robots.
primary goal is to
Some sound more
assist people
female,
with
some sound
cognitive
more male,
impairments,
and we haven't found any
like
difference.
Alzheimer's disease. One of the first things I can help with
So
is
let me show
regulating.
you the scenario.
It's delicious.
Okay, so this is, this is CASPER finding a person. So we actually have person search algorithms that are working in the background.
Derek, are you here?
Yeah, I'm over here.
Casper slowly goes to find Derek. And we set the speeds to be the natural walking speed of older adults.
Hello, Derek. It is time for lunch. Let's go to the kitchen to prepare something together.
Okay.
And then the robot can escort Derek to the kitchen. And so we developed an app that has
Please select a
some
recipe.
recipes that you can choose. Oh, good.
Thank
And you can see the letters are all large. Your favorite recipes can be in there.
3 ingredients.
Once you choose it, the robot will put
Let's
ingredients
find the
in you.
bread.
Okay.
And Derek's looking for the bread now in all the wrong places. And you can ask Casper
If
where
you
the bread
can't
is.
find the bread, I would be happy to show you where it is.
So just press the question mark and Casper can tell you. Lucky for Derek, everything is in that cupboard, just for demo purposes. Or we'd be here for half an hour when Derek was in the kitchen. So he finds the ingredients. Now, if you don't know how to do a step, Casper can also show you a video.
If you have all
of
the
the step.
required ingredients.
Okay, so now Derek has it. So here's, for example, a video of opening the can of tuna. And you can play it as many times as you want, and there's a video for each step. So once you're done making the sandwich, then the robot can escort you to the dining room, and then we can now implement what we had before, which was the meal eating
It looks
monitor.
very delicious. Please enjoy your meal at the table.
And then you follow the profile. So we did some user studies with older adults, and in this case we made the activity a little bit more simple, but something they like to do, which is afternoon tea. So to make a cup of tea. And what we wanted to see is how obviously they react to the robot, and then the compliance as well, to see, do they go through the steps that the robot is prompting them through. So this just kind of gives you an idea of that. And you can see how she mimics the robot with.
My name is Casper. What to meet you.
You too.
I am a personal assistant for your home.
So, first step, fill the kettle with water.
Try pulling the silver lever towards you.
And again, there's videos. I know you can't see this angle on the tablet. And you notice that she always turns
Try filling the kettle under the water.
that engagement there. And she's waiting for the next step. Okay, so that's, let me show you one more. And then pouring the cup of tea. So now we ran this with CASPER. Then we did the same thing with the tablet. Because people usually say, well, why do you need a physical embodied system? Why not just have the same video?
That cup of tea smells wonderful.
You like tea.
Thank you for making tea with
Again, the
me.
utterances you see to the robot.
Thank you for helping me.
Let's go back to the living room where we can enjoy your...
And so it was interesting to compare the two. And what we found between the tablet and the robot was the engagement was obviously higher. In most cases, they just ignored the tablet. They wouldn't look at it. It was just sitting there, right? Whereas the robot is a moving system. It has the facial expressions. You see the gestures, right? The pointing gestures, as well as the gestures kind of matching when it's talking, similar to talking with its hands. As well as compliance was higher with the robot versus the tablet. So they would just ignore it, really, in that sense, which told us a lot. So this idea of having a physical embodied system was a lot different than just having this 2D screen in front of them. And if we're making these more affordable, then it also promotes the use of the technology. The other issue with tablets are they're passive, right? So you have to remember to plug them in to charge. You have to be able to upload and run the software yourself, whereas the robot can do that all autonomously. So I talked a lot about one-on-one activities. What we wanted to look at was also group activities. How do people interact in groups with a robot? And that was important to us because we want to promote social interactions amongst the residents as well. So we have our TANGY robot. And TANGY does two tasks. The telepresence, which is very common. So this was the task that promotes connection with your social networks and interaction and so on. And it's really, maybe you could call it a Skype on wheels. So your family member, what they could do is go online, schedule a time with the robot and the resident, and then the robot would go find the resident and start the interaction. And all the resident has to do is just accept it. And we also said that they could deny it too if they're too busy and they don't want to interact, right? We want to give them that option. And so this is what it looks like. So there's a lot of telepresence robots out there already, but they're usually teleoperated by someone. And this is all done autonomously by the robot trying to find the person in the environment and then starting that interaction. Okay, so once the robot finds the user.
Hello, John. Your son wants to do a video conference with you right now.
Not as human-like as
if you are
right?
available, just press the green button on my screen.
Hi there, how are you doing?
I am fine. How are you doing?
Pretty good.
I haven't seen you for a long time.
Father doesn't say that. So then that's kind of how you can set up the interaction. When you're done, you would then, the robot would just go and then go to the next person. So you can have this in a long-term care facility where you just go online, set up an appointment, or the resident can set up verbally an appointment with the robot as well, and then the robot can alert the family members. Okay, so let's talk about group-based activities as well. So bingo is a popular activity that's played in a lot of long-term and retirement homes that we visited. So we decided to develop the robot to autonomously facilitate bingo games, call out bingo numbers, check bingo cards if there's missing numbers that are not marked or the numbers are marked incorrectly, and then celebrate when someone actually wins bingo. And you know, there's obviously advantages to a lot of the activities that we've been talking about. Bingo helps improve memory, recall, recognition, as well as motor skills for picking up the markers and placing them on the cards themselves. So here's TANGY. Here's TANGY actually. Let me just go back. Displaying the numbers, and then these are the bingo cards we developed for them. And you can see that the numbers are larger for our older adult participants. So what we did was, for both those activities, before we even started the user studies, was we did a focus group with older adults, the caregivers, as well as family members, with respect to TANGY facilitating both the telepresence and bingo activities. Its physical appearance, because it looks different than our human-like robots, but still has human-like capabilities, as well as what else do they want the robot to do for them. So you can see with response to bingo and telepresence, both activities were positively received. They wanted the robot to provide help for that, and especially the busy staff said it would be great during those recreational times that they could do these activities for them so they could do other things. The other thing was interesting, the physical appearance. So the residents had no real opinions about it. They were indifferent to it. They thought it's a robot, it should look like a robot, period, right? And that was it. The caregiver said maybe you could put a cardigan on the robot and a name tag, so it's interesting to see the difference, right? So that it would be part of the staff. It's interesting, right, to see those opinions. And we also, there was a lot of other activities that were pointed out. Obviously, reminders was a big one. The staff at the location we went to, I think they were saying that about 70% of the residents don't speak English as a first language, and so they have communication issues when it's time to interact with them to see what's, in case of health, or if something, they have pain, they can't figure out what's happening, they have to usually call family members. And can they use the robot as a translator? So could the robot help to provide that information on the spot? And that would be very helpful for them. And they wanted the robot to provide them with reminders as well. So for example, for bedridden residents, so the robot could come remind them to turn them over. So it was great to see that they were seeing the robot as a useful tool as well, not just for the residents, but for themselves. So this would be easier for us to integrate the robot into the care staff. So what we wanted to do though is bingo can be played differently, and we noticed that in different homes, there was different types of ways that the robot's behaviors could be implemented. So we gave the care staff the robot and said, why don't you teach TANGY how to facilitate bingo? So they were in charge of what the robot said and the robot's gestures, and I'll show you a video of them teaching TANGY. And this allows the care staff to actually customize the robot.
Gesture recording has started. Please move slowly so I can follow your movements.
Teaching the robot how to wait. And you can see the robot, we call it learning from demonstration, so the robot just repeats whatever the person does. There's a GUI that we designed, so the interface, you can type in whatever you would like the robot to say, or you can verbally say it, but if it's in a crowded environment, it may be easier to
Hello everyone. Who feels lucky today? Does everyone have a card?
So that's the behavior, and I'll show you, so this is calling out.
The next number is I-20.
You can set the background music if you'd like as well. And then the robot points to a screen where it displays the number as well. And you can also design the robot to come over to check the card. So you're seeing the camera's point of view in the environment, and then as well on the robot. So, okay. So here the robot is learning to come over to check the card. Okay, and then it uses its overhead camera to check what numbers are marked. So once we did that, then we actually deployed the robot with residents to see how the robot implemented behaviors and what their reactions were to the robot. So we had 7 participants interact, and I think it was about 4 one-hour-long bingo games. They were quicker if people won bingo earlier. And we wanted, there was 4 one-hour bingo games, but each resident interacted with the robot twice. So they came to 2 bingo games. And
play bingo with you today.
You can see that's the way that the robot learned.
It is one of my favorite games. Let's play bingo.
So calling out bingo numbers and then displaying them. And then the elevator in the background.
Oh, 69. Oh, 69.
So and it repeats twice. So twice it will say the numbers, it repeats once. It also
How about a joke? Where do snowmen keep their money? In snowbanks.
And then you can call it over to provide
Gee, 52.
So there was 2 ways of doing this. You could raise your arm. But we noticed that some older adults can't raise their arm very high. So we also gave them this green button that they could press, which
please give me a second to help
and then the robot uses that to localize it. So, and then depending on when you press your button, it just goes into a queue and the robot will help everybody in that order. So here he goes over to the card. Once it's done there, it goes to the next person. And show you a video of how that assistance is provided. So,
let me take a look to see how you are
if
doing.
the robot can't see the card, it'll ask you to actually move it up as well. So no other humans intervening in the game. And then it'll tell you if you've missed numbers, if you mark them incorrectly, and it'll display that information as well. So here's I'll move away because it uses gestures as well.
Oops, you have some misplaced markers. Please remove these markers from the following numbers on your card. in the end column can you remove?
Looking and seeing, watching her as she's subtracting.
And 39.
And then you can see it combined. Then of course,
US.
the favorite one is probably celebrating winning college. Not our choice.
Congratulations, you have won bingo.
What? That's funny.
A robot dance. Not really. We let the robot decide. So we're just finishing some of these studies. We did trivia as well, and we are obviously looking at engagement and compliance. And you can see that they're high for both activities. The great thing about trivia is it promotes the social interactions more than bingo does. So they were talking to each other in bingo, but it was great in trivia because they were playing in teams, right? So they would talk to each other, obviously, for the answers, but they would also say, you know, who wants to press the button to call the robot over? And so they would take turns doing that, which was nice to see. So that was great, and that promotes the social interactions. So both activities promote social interactions with residents, amongst residents themselves. I'll do one more. Activity of daily living, clothing activity. I really need one of these early in the morning too. That's great. So this is our robot Leia, and it's a little smaller version, a little humanoid desktop robot, but it has a lot of expressions because it can move its legs as well, rather than just a mobile base. And what it does is recommend outfits out of your wardrobe. And so we've developed a little app that takes you through those steps, and the robot has a lot of expressions for getting you through those steps. So I'll show you this one. In September, we'll actually be running a user study with Leia. So we just finished the demo.
Hey there, John.
Hi. Here's Leia.
I'm Leia, your personal wardrobe assistant. My job is to
She has
help
a
you
brother
pick out
named
what to
Luke.
wear today.
So you can see the graduate students.
First, I'll need to know what you're doing
Leia.
today. There are many preset activities available. Or
So you can choose a preset activity, or
on the touch screen,
add in your
let
own.
me know what type of activity you're planning.
And you see the colors of the eyes changing? That's how it displays facial.
Great, you chose outdoor walking. Give me 1 moment to come up with your recommended outfit. Okay, here is your clothing recommendation for the day. I recommend you wear your gray hoodie, your navy jeans, your black windbreaker, and your white Vans sneakers.
Okay, the wardrobe's obviously for graduate students. But in general, it would be for the older adults wardrobe. No, I don't. I'm not trying to make people wear a hoodie or Vans.
That's too bad.
So if you don't like it, you can tell the robot, and it will provide another
Let me
option.
know if you want to replace the whole outfit, or just part of the outfit.
I think I'm going to replace the shoes.
And so we have this learning algorithm that is adapting to your responses. So if you don't like something, it knows not to recommend that for the activity and whether next time. And it'll eventually find what your favorite outfits are for the activities. But of course, if you choose summer clothes or going outdoors in the winter, it will provide recommendations based on the weather.
Your black windbreaker, and your gray desert boots.
Okay, and then you can approve
Use
it.
the screen to let me know if you like it or not.
Yes.
Great. I'm glad you like it. I'm sorry that I could be of assistance.
You can see the green now in the eyes.
Hope you have a great rest of your day.
Thank you.
Bye for now. Hope to see you again soon.
Bye.
So that's Leia. So I'll stop there. So I'd like to thank all our lab members that have been designing our robots. We have our new blueberry robots here too. You can see There's 2 of these, and in August we'll be deploying them in a long-term care facility for a month at a time. So instead of, if you notice, most of these studies have been kind of, here's the activity, the robot goes in for a few times, but we'll just leave them there autonomously to work for a month, providing assistance for the telepresence, the bingo activity, as well as the reminders, and see what happens during that long span. Because these robotic studies, because it's such a new area, haven't been done for long periods of time yet. So it'll be interesting to see the uptake. There's obviously a novelty effect with any technology, right? So because the robots are adaptive, we're trying to minimize that novelty effect, that they get bored of the technology and not use it anymore. So you can see with the expressions, personalizing the interactions, that we want to promote continued engagement. And all our funding sources as well. Okay, thank you so much.